to the above numbers, we obtain as follows. Here we know that A is equal to BQ plus R. So when 20 is divided by 8, we obtain quotient Q as 2 and remainder R is equal to 4. Substituting the obtained values of Q and R in the above expression, we obtain both LHS and RHS equal. Similarly, let's consider second set of numbers 17 and 5. Here, A is equal to 17, B is equal to 5. Thus, by applying the Euclid's division lemma, EDL, to the above numbers, we obtain as follows. Here we know that A is equal to BQ plus R. So when 17 is divided by 5, we obtain quotient Q as 3 and remainder R is equal to 2. Substituting the obtained values of Q and R in the above expression, we obtain both LHS and RHS equal.
Will your child win free education for life? Book a free coding class.
Sir, in Euclid's division lemma, the term lemma sounds differently. I never heard about it. Lemma is the typical word to hear and pronounce, but it is just a result. It is used in proving the other theorems. Suppose one wants to compute the HCF of two numbers. The most common method used is factorization. But to compute the factorization of large numbers, such as 65,842, 24,895, and so on, is very difficult and takes a lot of time. So Euclid has came up with a theorem that would help us to find the factorization method easily in less time. This theorem is very simple and is just another form of divisibility rule, which we have studied in our lower classes. Sir, could you please explain us the theorem of Euclid's? Okay, listen to the theorem statement. Now, let us know theorem on Euclid's division lemma. Statement: if A and B are two positive integers, then there exists unique whole number Q and R, such that A is equal to BQ plus R, where 0 less than or equal to R is less than B. Do you remember the divisibility theorem? Dividend is equal to divisor into quotient plus remainder. The Euclid's division theorem is originated from this. Sir, but how is it possible to use this theorem to find HCF? Can you please explain us more clearly in simpler way by taking few examples? To understand more clearly, first let me explain the theorem by an algorithm, step-by-step manner and flowchart. Algorithm. An algorithm is a step-by-step procedure or formula for solving a problem. The word algorithm has come from the name of the Persian mathematician Al-Khwarizmi, earlier transliterated as algorithm or algorithm. The word algebra is also derived from a book which he has written called Hisab al-Jabr wal-Muqabala. Euclid's division algorithm is used to compute the highest common factor, HCF, of two given positive integers. To obtain the HCF of two positive numbers, say A and B, follow these steps. Step 1. Apply Euclid's division lemma to A and B. So there exists whole numbers P and R such that A is equal to PP plus R, where 0 less than or less than B. Step 2. If R equal to 0, B is the HCF of A and B. If R is not equal to 0, then apply division of lemma to B and R. Step 3. Continue the same process until the remainder is 0. The divisor that is obtained at this stage is the required HCF. Flowchart. Here, let us know sequentially in the flowchart to keep the steps to find the HCF. Let the first number be A and second number be B. If A is greater than B, then according to Euclid's division, lemma A is equal to PQ plus R, where Q and R integers and 0 less than or equal to or less than B. Suppose A is equal to BQ plus R. If R is equal to 0, then B is the HCF of positive numbers A and B. If A is equal to BQ plus R, if R not equal to 0, we apply the division lemma to B and R and continue the process till the remainder becomes 0. If A is less than B, then according to Euclid's division, lemma B is equal to AQ plus R, where Q and R are integers and 0 less than or equal to or less than A. In B is equal to AQ plus R. If R is equal to 0, then A is the HCF of positive numbers A and B. In B is equal to AQ plus R. If R is not equal to 0, we apply the division lemma to A and R and continue the process till the remainder becomes 0.
Whatever I see that she has achieved in the last year or so would have been very difficult had that.
Now, let us do some examples by taking small numbers first and then large numbers. To understand the Euclid's division lemma more clearly, let us find the HCF by considering following pairs of integers. A. 24. Step 1. Apply EDL to the above numbers. Here A is equal to 20, B is equal to 4. Substitute the values in A is equal to BQ plus R. So when 20 is divided by 4, we obtain quotient Q as 5 and remainder R is equal to 0. Substituting the obtained values of Q and R in the above expression, we obtain both LHS and RHS equal. That is 20 is equal to 4 into 5 plus 0. As the remainder is 0, the process stops. The divisor at this stage is 4. Therefore, HCF is equal to 4. B. 4032, 262. In the given pair, 4032 is greater than 262. Therefore, let A is equal to 4032 and B is equal to 262. Step 1. By applying EDL relation A equal to BQ plus R, where 0 less than or equal to B less than R, we get as shown. So, 4032 is equal to 262 into 15 plus 102. As R equal to 102, which is in turn not equal to 0. Now, apply Euclid's division lemma to 262 and 102. Step 2. (262) is equal to 102 into 2 plus 58. As R is equal to 58, which is not equal to 0. Apply Euclid's division lemma to 102 and 58. Step 3. (102) is equal to 58 into 1 plus 44. As R is equal to 44, which is not equal to 0. Apply Euclid's division lemma to 58 and 44. Step 4. Here 58 is equal to 44 into 1 plus 14. As r equal to 14, it is not equal to 0. Apply Euclid's division lemma to 44 and 14. Step 5. "44 is equal to 14 into 3 plus 2. As r equal to 2, it is not equal to 0. Apply Euclid's division lemma to 14 and 2.